Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Rat Run 27, Productivity by Marty Sears. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Aim of experiment. F and P must both reach different cupcakes by finding a path through the maze. The paths must not visit any cell more than once, share cells, cross themselves or each other, or pass through any thick maze walls. So interesting, we have one rat just right next to another, right next to a cupcake. And then the other rat has to run, or I guess, actually, that's interesting. One rat could just go right there to next to the cupcake, and then the other rat could have to run all the way around here for this cupcake. Or this rat could reach to this cupcake here, and then this rat would have to avoid the other rat because they cannot cross cells, share cells, cross themselves, or pass through any thick walls. I don't know which one's F and which one's P, but I don't know. I think usually the topmost one I think is F usually, and P is usually the bottommost one, but I don't know. I usually go from left to right. Who knows? Anyways, that is the paths. As well as moving orthogonally, sorry, that's not all the paths. This is also a constraint of the paths. As well as moving orthogonally, they may move diagonally if there is a 2x2 space in which to do so, but may never pass diagonally through a round wall spot on the corner of a cell. So you could not have a path going something like that. That's not allowed because there's a corner wall spot there, and the rats cannot go diagonally if there's a corner wall spot in the spot they're trying to go diagonally through. You could have a path do something like that, though, because this is perfectly valid because there's no corner wall spot for this to go through. And that is how the paths work. Or how they can move, I should say. Golden berries. If two digits are joined by golden berry, they are not consecutive. So, if this were, say, a 6 here, this would not be a 5 or 7. It could be any other digit, but it cannot be a consecutive digit for two digits that have a golden berry in between them. Test constraint. In this experiment, both paths are divided into segments, by 3x3 box borders. Along a path, the digits on each segment have the same product. The result of multiplying the digits on the segment together. And this product may be different for F and P. Note, if a segment contains only one cell, that digit is considered to be the product. Okay, so the reason why this I guess F cannot go just straight to this cupcake here is if she did, these products would have to be the same, and therefore they would be the same digit, and therefore we'd have a repeat. We'd have a repeat in that row, which is not allowed. Yeah, but on each, so for the paths, you divide the segments into 3x3 boxes. So say F went something like this. Well, that's not possible either, huh? I'm sort of already solving this anyways. Let's say P went this path. The 3x3 box borders divide each length on this path into segments. and the product of each segment must be the same product. So these three cells multiplied together must equal the same as this cell, which one must be equal the same as these four cells, and obviously we're starting to have an issue here, which is the same as the product of these five cells. So obviously there's going to be some sort of issue with this. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so we know F cannot go straight this way because they would then have to have the same product here and therefore be the same digit, which is not allowed. So F is blocked from going this way. Now, can F go this way? The problem with that, so say, I guess she could, technically, but that means she cannot go this way. What about going all the way around here? Can she go this way? I think the answer is no, right? Because then this would be the product of 1, 2, 3, 4, 5, 6, 7, 8, sorry, 8 digits, which is at minimum 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8, which is a very large number. And then this would be the product of 2 digits. So F can never go this way to the cupcake. So F is definitely going this route. So F can go here, has to go there first, and then could go here. It cannot go. Could potentially go around there. That's 5. It could go straight down. It could go this way. Can 2 digits multiply to what 5 digits multiply to is kind of the question. So can this cupcake be reached by going around this way? Actually, this is guaranteed to have only 2 digits. Huh. Interesting. Obviously, 2 digits can't multiply to what 8 digits multiply to if we have the 8 unique digits. Well, they have to be unique because can you have 2 multiply to what 5 digits multiply to? Maybe 8 and 9 are the largest that you can have. So 8 and 9 is 72. Divided by 1, obviously. 2, 3, 4. Minimum 2, 3, 4, 5. So 2, 3, 4 is multiplying to 2 times 3 is 6 times 4 is 24, which is 120 at minimum. So no, 2 digits can never multiply to what 5 digits are. So therefore, we cannot go this route. So this route is closed because it has to have at minimum 5 digits here and then 2 digits here. So this has to be minimum 2 digits coming from this way. So therefore, this goes out this way and cannot be just directly straight to F, because then these digits would be the same product, and that's not allowed. But it cannot cross to P. P cannot cross to this one, because P, if, say, we do something like that, that blocks F from ever reaching the other cupcake because they cannot cross paths. So F cannot go this way or that way. So F is going to have to go through this path here. or this path? Well, we know we can't be the product of 5 digits, so it has to be at least at most 3. P has to go then through this path, and then eventually through here. So F is going to have to go this way. And then, oh, it has to go that way. So the product of 2 digits has to be a single digit. How does that work? How does that work? Because the only way I can see is that this would be 3 that way. You can't have a single digit here, so you have to go here. Oh, I guess you could do something like that. Okay. So it has to be a single digit, which I think it has to be 1, 2, and 4 then. Um, right. You're gonna to have a singleton digit as the product, and to be able to multiply 3 digits together to get that, it's 1, 2, and 4 multiplied to 8. So this is at most 3 going this way. So it can go 1, 2, 3, 1, 2, 3. So this has to go something like this. It cannot be. So the only digits which multiply into 8 are 1, 2, 4, and 8. So this can we have a full 1, 2, 4, 8 here. This is 3 digits multiplying to 3. So this must be 3. It cannot go here then diagonally, so it has to go here then here. This has to go here then here. So that's F's path. And this is 8. That leaves, this is 3 digits multiplying to 8. This is 3 digits multiplying to 8. So this has to be 1, 2, and 4. And this digit cannot be consecutive with either of these. So this cannot be 1 or 2. This must be 4 here, which means this multiplies to 8 if this is 1 and 2. This can't be 4, so this is 1, 2, and 4. This has to be, this cannot be 8 here. 3 digits multiplying to 8 is 1, 2, and 4. So this can't be 1, this is 1, 2, or 4, cannot be 8. It has to be 2 and 4 here. Therefore, this 2 digits have to be 1 and 8 here, which eliminates 1 and 8 in the rest of the column. So this is 2, 4, 2, 4. We have 1, 2, 4 there. This cannot be, well, this could be 1 if that's, okay, 4 eliminates 4 here. So that's 2, which means this is 2 eliminates 2 here, so that's 4, which makes that 2. 2 is not consecutive with 1, or sorry, is consecutive with 1, therefore this can't be 1, that's 8, that's 1. That eliminates 1 being here. P cannot go through this path, because then she would cross paths. So she has to go that way. That's gonna be interesting. We have 2 digits multiplying to what these digits are. How is that going to work? Remaining digits in this box then could be 8 or so 3, 5, 6, 7, 8, and 9. Okay. Remaining digits in column 2. Column 2 has to be 3, 5, 6, 7, 8, 9. Column 3 is 3, 5, 6, 7, 9. No 8. This can't be 8 in box 7. Remaining digits of column 4 are 3, 5, 6, 7, 9. Column 5 have to be 3, 5, 6, 7, 8, 9. So no 8 here. Remaining digits of row 7 are 1, 3, 5, 6, 7, 9. Okay. Can you ever have 2 digits here? Remaining digits of box 1 are 3 through 9, so our column, or box 4, are 3 through 9. Remaining digits of column 1 have to be 2 and 4. Because 2 and 4 can't be here because of the 1, 2, 4 triplet in the box. Can't be here because of 1, 2, 4 triplet in the box. Can't be here because of the 2, 4 in the row. So this must be a 2, 4 pair here, which forces this to be 1, which eliminates 1 in the rest of the row. That's interesting. So it must contain a 2 or 4 here as a product. Therefore, we're guaranteed an 8 has to be on this path here. And the only, well, could go 2, 4 here. But then we'd have to have 2 other digits multiply 2 a single digit here, which is not possible. So you cannot go this path. Which means 6 has to be on this path here. So that it must be 4 being here and 2 being here. Because we need to multiply 2 and 8 as a product. And the only way we have that is 2 as part of the 6. This has to be 4, 6, and 3, I think, right? Because 4 times 6 is 24, and then you have another thing multiplied together. And again, 2 digits can only multiply to 72 at most. So this has to be an 8-9 pair here. That eliminates 8, 9 in the rest of the column and the rest of the box. So no 8, 9 here. This can't be 3 because that's consecutive with 2. So this must be 4 with 3 and 6. I don't know how I got that one. This can't be 5, 7, or 9 then. This can't be 5, 7, or 9. Or you could have a 9 here, technically. This also has to be 4 digits here in some path with the 1, right? So 1, 3, and 6 multiply to 72. So we have 2 3s that have to be in the factors and 2 2s that have to be in the factors. Sorry, 3 2s have to be in the factor. Well, this cannot contain two or 4. That's going to be a problem, though. Oh, it could just be 3 digits, though. Then goes there, and cannot be 5 digits. Yeah, that seems more likely what's going to happen. You have 3 digits, 9, 8, 1. What? So you can't have 4. Can you ever have 4 digits without 2 and 4 to multiply to 72? I think the answer is no there, right? You obviously have 1, but the problem is you need 3 2s in the factorization, and you need 2 3s. So the problem is 3, 6, and 8 multiplied to, that's too big. It's basically 144, I believe. 3, 6, and 8 multiplied to 172 times 2, which is 144. Because 3 has 1 3, 6 has 1 3, but it also has a 2. 8 has 3 4s. Or, sorry, 3 2s, which is 4 2s then, which is too many. So it has to be 9, 8, and 1 then here. And any other way going through here has to go 1 2 that way if it goes any other way but just straight. So this has to be just straight through. And then exits out. So this must be then 8, 9, and 1? Right, because you don't have any way to get 3 2s on the dot except for with just the 8, right? 6 has 1 2, and every other digit in the box has 0 2s. So you have to have an 8 here. So then this has to be 9, 8, and 1. So we have 9, 8, and 1 there. That eliminates 8 and 9 in the rest of the columns and boxes. So no 8 here, no 8 here. No 9s here, no 9 here. This is 3, 5, 6, 7. You cannot have 5 digits multiplying to 72, like we just discussed here. So you could potentially have 3 digits here. You can't have a singleton digit multiplying to 72, and the remaining digits in box 8 cannot multiply to 72 because we have only one access to 1 2 available in the factorization. So we can't go back into box 8. We have to go here. So then we have to go through here. So this has to be P's path here. And then has to go through here. It could potentially be 2. It could be 1 going that way. You cannot go, yeah, you can't have 5 digits, so you cannot go that way. So she either has to go like that and then back through. Oh, that's interesting. So she has to go this way. So she has to go this way and could just go directly to it, potentially. 3 digit, and we do have 2 and 4 available in box 9 and box 6 and box 3. Interesting. Okay. Remaining digits of box 5 is 3, 5, 6, 7, 8, and 9. 1 has to be one of these 3 digits here. So 3 digits multiplying to 72 is quite valid. This can't be 9 because of 9 in the row. This is 3, 6 as a pair, which means this cannot be, this can't be 3, 6 because 4, 3, and 6 multiply to 72, which is what we need. And 3 and 6 has to be one of these two, which means these can't be 3 or 6. And 7 and 9 is consecutive with 8, so this can't be 7 or 9. So it's 5, which eliminates 5 in the rest of the box and column. Remaining digits of row 9. We have 3, 4, 6, and 7. And 5. So 4 and 5 are guaranteed to be... 5 eliminates 5 in the rest of row 7. So we have 1, 2, 8 as a triplet remaining in row 8. Interesting. If it's 2 digits, this is 8 and 9 here. Can this ever be 1? I don't think so. 1... Yeah, 1 would have to be with 8 and 9, and this can't be 8 or 9. So this can never be 1 here. Maybe 2? Maybe 2 is possible. Yeah, you could have 2, 4, and 9 there. What about... So either this is 8 and 9. You would have to have 2, 4, and 9 there. So either way, this is a 9. So this is 9, which eliminates 9 in the rest of the box. This can't be 9. This has to obviously be part of it. It cannot have 5 or 7 because that is not going to be divisible, dividing into 72 correctly. What else do we have? So cannot be a full set here. Has to exit out somewhere. So cannot just go straight through. Okay, that's definitely not going to be able to work. Could be... Can't be 2 here because we need a 9 for that. So cannot go this way, this way. Can't be a singleton here because that's 2 digits must multiply to 72. And 1 digit cannot be. So cannot go 1, 2 there and then exit out because that can't have a 9. Can't be 3 because then we would guarantee... Well, first of all, if it's 3 this way, it would exit out that way. So this can't be, I don't think, 1... Okay. Can't go 2 with an out here because that requires 8 and 9 to be here, and we have a 9 guarantee there. Can't go out just 1 because that's too big. And then if we go 3 here and then back here, this is going to be way too big for 72. So this path has to go this way. Can't be a singleton. So it must be 2. And it must be 8 and 9. So this is 8, that's 9, which eliminates 9 in the rest of the column. And box. No 8 and 9 here. Okay. Has to essentially go around here. And again, we can only have 4 digits at most. 2, 3, and 4 times 5 is 120, which is the smallest 4. Oh, okay. I guess. Yeah, 1, 2, 3, and 4 could be 4 digits. But 5 digits is guaranteed to be 1, 2, 3, 4, 5. So cannot go here and here. It has to come from that path. Okay. This is going to be 3 digits then here. Where is 9? 9 can't be here. So remaining digits in column 6 is 2, 4, and 9, which exactly multiplies to 72. Okay. This is 3 digits multiplying to 72. We do not have 9 available, so therefore 3 and 6 must be here to provide the 2 3s that we need there. So this is 3 and 6, and then multiplied with 4, right? So multiplied to 72. 33 times 6 is 18, times 4 is 72. So this is 3, 4, and 6, which eliminates 3, 4, and 6 in the rest of the column. So this cannot be 2 and 4 to multiply with the 9. It has to be 8 and 9. So this is 8 and 9, which eliminates 8 in the rest of the box. Therefore, the path must go, P must go that path. That leaves this as, so this cannot be 1 here. We have 3, 4, 6 here. The remaining digits of column 7 are 1, 2, 5, and 7. Obviously, 5 and 7 cannot be there. If we have a 2, we don't have access to a 1, and therefore this would multiply to greater than 72. So this must be 1 here. That eliminates 1 from being here and here. So one of these is a 4. This would be 1 here. 2 is one of these two. 2 is guaranteed to be in rows 2 and 3 in box 1. It's guaranteed to be in rows 2 and 3 in column 7. So therefore 2 cannot be in the rest of rows 2 and 3. So 2 has to be there. Without the 2, we need 3 digits to multiply to 72. And that has to be then 3, 4, and 6. So this is 3, 4, or 6 here, guaranteed. We need one of the 4s, and 4 cannot be any of these digits here because we have a guaranteed 4 in column 3 in one of these 2 cells. We have a guaranteed 4 in one of these 2 cells in column 6. So therefore 4 cannot be here. So this must be a 4 here because we can't have 4 digits to multiply with the 1 to multiply to 72. So then this is not 3 or 6 here. So this has to be 5, 7, 8, and 9 here as possibilities. These has to be 3, 6, 5, 7, 8, and 9. And this cannot be 3 or 5 because it's consecutive with 4. 4 eliminates 4 from being here. We need access to 3 2s in this set. And this is 3 or 6. This is 3, 6, 7 as a triplet, which eliminates 3, 6, 7 in the rest of the box. And this can't be 7 because of 7 in the row having to be here. So this can't be 3, 6, or 7. It's 5. This has to be 4. 3, 6 as a pair eliminates 3, 6 in the rest of the row, so this can't be 3 or 6. It's 7, which makes this 9. This cannot be 7 or 9. It's 3 or 6, which means P has to go that path. We have to go through the 4, so it has to go through there, then there. And 7's never on the path. So 3, 4, and 6 multiply to 72, which makes this 1 and that 2. This can't be 3 or 6. It's 7. Okay. So can we ever get to get 3 sets of 2? We are guaranteed this is a 2, so we need the 4, and we need then we cannot get the 6, so therefore we must have 4 and 9. So this has to go that path. Remaining digits of... So we don't have 3, 4, or 6 available in box 6, which means we have to have either 9... We definitely have to have 9, and it has to be 9 with either 8 or with 2 or 4, and then maybe with 1. So remaining digits in box... This 1 eliminates 1 from being here, so this must be 1 here. So this is definitely on the path. Remaining digits of box 6 are 2, 5, 7, 8, 9. So no 2 or 7 here because of 2 or 7 in the column. This 5 eliminates 5 from the rest of column 7, so this is 2, 7 as a pair, which eliminates 7 in the rest of that column. This cannot be 5 or 7 here on the path. Yeah, it has to, it can't, there's no 4 available. So it's 1, 8, and 9. So the path has to go from 1 to 1 of 8 or 9 to 8 or 9 here. So this cannot be 8 or 9 here. We actually have a 5, 8, 9 triplet, which eliminates 5, 8, 9 in the rest of the box. So this is 2, 7. 5 has to be one of these two, so this can't be 5 here. So cannot go that path, so has to go this path here. 1, 2, 3. So this is 8, 9 as a pair. That eliminates 8 and 9 here, so this can't be 8 or 9. It's 5, which eliminates 5 in the rest of the row. Okay. 3 and 6 cannot go straight down. So she has to cross here or here. We don't know which. 2 eliminates 2 here, so that's 7, which makes that 2. Which eliminates 2 here, so that's 1, which makes that 2. 1 eliminates 1 here, so that's 2, which makes this 4, which makes that 1. 4 eliminates 4 here, so it's 9 and 4. 2 eliminates 2 here, so it's 7 and 2. 1 eliminates 1 here, so it's 4 and 1. That means 4 cannot be either of these, so 4 has to be here. 7 eliminates 7 in the rest of the row. Oops. Eliminates 7 in the rest of the row. 7 eliminates 7 here. So this is 3, 6 as a pair. 3, 6 eliminates 3, 6 in the rest of the column. So this can't be 3 or 6. Cannot be 7. This is 8, 9 as a pair, which eliminates 8 and 9 in the rest of the box. So where is 7 in box 4? It has to be here. 7 eliminates 7 being here and here. Okay. 7 cannot be here because of 7 in the row. 7 can't be here because of 7 in the row. 7 can't be here because of 7 in the column. Where is 7 guaranteed in box 1? It must be next to the Nabner or the Goldenberry, which means 6 cannot be here. So we're guaranteed 7 here. 6 has to be one of these two. Okay. 8 eliminates 8 from being here. No, where is 9 eliminates 9 here? So this is 8, which makes this 9. 8 eliminates 8 in the rest of the row. 9 eliminates 9 here. Where is 8 in row 1? It has to be here. So this is 8, which means this can't be 8. That's 9, which makes that 8. 9 eliminates 9 here, so that's 8 and 9. Therefore, there's no 9 here. This is 3, 5, and 6. We have 9 eliminates 9 here, so that's 6. This can't be 6 here. It's 3, 5 as a pair. 3 and therefore this can't be 3 and 6. This is 9. So the path has to go through the 6 and then the 3, then the 1. So this is 3, that's 5. So we've got the full path. Just to double check. 4 times 1 times 2 is 8. 4 times 1 times 2 is 8. 8 is 8. 4 times 2 is 8. 1, 4, 2 is 8. 1 and 8 is 8. 9 and 8 is 72. 1, 4, 3, 6. So 4 and 3 multiplied to 12. Multiplied by 6 is 72. 9, 8, 1 is multiplies to 72. 8 and 9 multiplies to 72. 4, 3, 6 multiplies to 72. 8 and 9 multiplied to 72. 4, 9, 2 multiplies to 72 because 2 times 4 is 8. 1, 4, 6, 3 multiplies to 72. 1, 8, 9. And this has to be 3, 6, 1, 4 multiplying to 72. So just finishing this off, 3 eliminates 3 here, so this is 6, which makes this 3. 6 eliminates 6 here, so it's 3. No more 3 here. This can't be 3, so this is 5, 6, and 7. If 6 were either of these digits, it would be consecutive with 5 or 7. So this must be a 5, 7 pair, which eliminates 5. This 3 eliminates 3 here. That's 6, which makes that 3, which makes this 6. 6 eliminates 6 here, so it's 5, which makes that 3. No 3s here. This is a 5, 7 pair, which eliminates 5, 7 in the rest of the box. So this can't be 5. It's 6. This can't be 5 or 6. It's 3. This is 6 again. These can't be 3. This can't be 5 eliminates 5 here, so that's 7 and 5. No more 5s there. It's 6, 7 as a pair, which eliminates 6 and 7 in the rest of the row. 3 and 6 eliminate 3 and 6 here, so that's 5. This can't be 5, 6, or 7. It's 3. 5 eliminates 5 here, so it's 7 and 5, which makes this 6, which makes that 7. This 6 eliminates 6 here, so it's 3 and 6. 3 and 6 eliminate 3 and 6 here, so it's 5, which leaves that as 3. 6 eliminates 6 here, so it's 7, which makes this a 6. Experiment completed successfully. Test date, February 25th, 1975. Cells visited, 44. Golden berries eaten, 4. Perhaps I've been spending too long in this lab, but I have a funny feeling I'm not the only one curious about Elliot. P also appears unusually attentive toward him. Several times I've caught her sitting there when he approaches, looking up at him with a sort of curiosity and compassion. Something I've never noticed from F. I don't know if I would consider this hard. It felt like that this was very constrained about the paths that you could go. So I felt like you had to go through certain paths. And you're really restricted. Anytime you have multiplication, you're really restricted on what digits can be multiplication multiplying to the same number. You're really restricted on what digits you can have included in them. So I would consider this challenging level difficulty, but maybe that's just me. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.